Today we have to find out the potential energy of a system of n point charges. For that, we have already seen that the potential energy in between the system of 2 point charges. In that, the last equation is potential energy U, which is equal to the 1 upon 4 pi epsilon 0, then charge Q1 Q2 upon R12. Right? Now this will be the potential energy of a system of 2 point charges. But now we want to find out the potential energy of a system of n number of point charges. For that, first of here we want to consider this will be the reference system. Right? This will be the x-axis, this will be the y-axis, and now this will be the z-axis. And now this will be the origin. 0, 0, 0 is the origin. First of here, the n number of charges which is placed at infinite position. Suppose this will be the first charge, this will be the second charge, and now this will be the nth charge. So these charges which is placed at infinite position from the reference system, and again the distance between all these charges which is also infinite. So that's why no one charge which acts the force on each others. Right? Then in that case, first of here we want to bring the first charge Q1 and we want to place at the point A. Right? The distance of point A from the origin, suppose that distance is there R1. But for charge Q1, their work done is 0. Because of when we move the charge Q1 from infinite position to this position, at that time there is no opposition, that is no electric field. So that's why their work done is 0. Now we want to bring the second charge from this infinite position to the suppose position is there B. Right? Then the distance of point B from the origin, suppose that distance is there R2. Then when we place the second charge Q2 at point B, at that time the first charge which acts the force on the second one, because of we place the second charge in the vicinity or electric field of first charge. So that's why the charge acts the force on the second one. So we place the at the point B. So that's why their work is done. Suppose here if we consider the distance between the first and second charge is there R12. Then at that time in between these two charges their work done is, that is work done for the second charge, which is equal to the, what we get there. Again we want to use the same formula, that is 1 upon 4 pi epsilon 0, right? Then charge Q1 upon, now their distance is R12. R12 is the distance between these two charges. So that's why here we keep the R12. And now again here we want to keep the magnitude of second charge is as it is. Right? Now this is about the work done for the second charge. Suppose this will be the equation number 1. Right? When we move the second charge from infinite position to the position B, then at that time this much amount of work is done. Now we want to bring the third charge from infinite position to this position. Suppose this will be the third charge, and the distance of this third charge is what you get there, R3 from the origin. But the distance between the second and third charge is R23. Then from first to third charge is what we get there, R13. When we kept the third charge from infinite position to this position, at that time there already in that field or in that region the two charges which is present, that is charge q1 and q2. Now both the charges which act as the force on the third one, right? It means that in between the first and third charge their work is done. Again in between the second and third charge there also work done. So that's why the total work done for the third charge is now work done for charge q3 is what we get there, w3, which is equal to the, here we want to take the addition of that is summation of work done in between the first and third charge and second and third charge. Now we want to keep the value of that work done. Here the value of W13 is what you get there, 1 upon 4 pi epsilon 0. Then their charge first and third one, and distance between them is R13. Similarly in between the second and third charge, what you get there, 1 upon 4 pi epsilon 0, then Q2 Q3 upon R23. So this much amount of work is done for the third charge, right? Then the total work done for the system of these three electrical charges, what you get there, total work done for system of three charges q1, q2 and q3 is what you get there. So total work done which is equal to the, what you get there, here the addition of these two work done, that is work done on second charge and work done on the third one, that is W2 plus W3. Here the value of W1 is 0 because of for single charge there the value of work done is 0. Now we want to keep the value of W2 and W3 is here. In that 1 upon 4 pi epsilon 0 is common, so kept outside. 1 upon 4 pi epsilon 0, then what you get inside the bracket, charge q1 q2 upon r12 plus, now this term what you get there, q1 q3 upon r13, and now their third term is q2 q3 upon r23. So this much amount of work is done for the system of three electrical charges. If you see this equation, then what you get there, 1 upon 4 pi epsilon 0 is common, but now here this will be the terms of all the combination, that is the combination of first charge, second charge, first charge, third charge, second charge, third charge. Again our distance is also same, that is R12, R13, R23. Right? Now this will be the work done for the system of three electrical charges. Then for the n number of charges, what we get there? So now total work done for system of n charges is what you get there in general term. So W which is equal to, sometimes this equation which is also written as in terms of the summation, 1 upon 4 pi epsilon 0. So what you get there, summation from I equal to 1 to 3. So what you get there, Qi then Qj upon Rij, right? So again for the n number of charges we write this equation, what you get there, 1 upon 4 pi epsilon 0, then summation from I which is equal to the I or j, I and j, Ij which is equal to the 1 to, what you get there, Ij n. Right? Now this will be the equation for the n number of charges, and next term is there qi qj upon rij. Right? So this much amount of work is done for the system of n number of charges, but we know that this work done which is stored in the form of potential energy. So that's why this work done which is written as potential energy. So what you get there? 1 upon 4 pi epsilon 0. So summation I j which is equal to 1 to what you get there n. So what you get there? qi qj upon rij. Right? So this will be the potential energy of a system of n point charges. See once all these equations. Right? Thank you.